Imagine standing under a quiet night sky, looking up, and realizing that the future of human connection is not buried underground in cables, but moving silently overhead at incredible speed. This is where ambition meets physics, where imagination collides with engineering, and where a simple question changes everything. How close do you need to be to truly connect? For decades, satellite internet accepted distance as destiny, assuming that being far away was the price of reaching everyone. Then Starlink arrived and refused that assumption, choosing low Earth orbit not as a compromise, but as a declaration that speed, accessibility, and human experience matter. This story is not only about satellites and altitude, but about a mindset that challenges tradition and dares to rethink first principles in pursuit of progress. Traditional satellite systems were built high above the planet, resting in medium Earth orbit or geostationary orbit, thousands or even tens of thousands of miles away. From that distance, satellites could cover massive areas, but they paid a hidden cost that users felt every day. Signals had to travel enormous distances, bouncing from Earth to space and back again, creating delays that made simple actions feel slow and frustrating. Video calls lagged, web pages hesitated, and online experiences felt disconnected. For years, this was accepted as unavoidable, especially in remote areas where no better option existed. Yet acceptance is often the quiet enemy of innovation, because it convinces us that limitations are permanent rather than temporary challenges waiting for a better idea. Starlink challenged that belief by asking a different question, one that echoes the engineering philosophy often associated with Elon Musk and his insistence on reducing problems to their core truths. Instead of asking how to improve traditional satellite internet, Starlink asked why satellites had to be so far away in the first place. Physics provided the answer. Distance creates delay. The closer a satellite is to Earth, the less time a signal needs to travel, and the more responsive the connection becomes. Low Earth orbit, positioned only a few hundred miles above the surface, transformed latency from a weakness into a strength. This shift was not cosmetic or incremental. It was foundational, redefining what satellite internet could feel like for everyday users. By placing thousands of small, agile satellites into low Earth orbit, Starlink embraced complexity in exchange for performance. Unlike a few massive satellites parked in distant orbits, this dense network moves constantly, handing off connections seamlessly as satellites pass overhead. The result is an internet experience that feels closer to fiber than to the sluggish satellite systems of the past. Pages load quickly, games respond smoothly, and video calls feel natural, even in places once considered unreachable. This was not achieved by ignoring the challenges, but by confronting them directly, accepting that launching and managing many satellites would be difficult, expensive, and risky. Progress often demands that kind of courage, the willingness to trade comfort for possibility. Yet beneath the technical choices lies a deeper motivation, one rooted in human potential rather than hardware alone. Connectivity is no longer a luxury. It is the backbone of education, opportunity, and participation in the modern world. When latency drops and speed increases, barriers dissolve. A student in a rural village gains access to the same knowledge as someone in a major city. A small business can compete globally. A family can communicate without frustration or delay. Starlink's decision to operate in low Earth orbit reflects an understanding that technology should serve human experience, not force humans to adapt to technological shortcomings. It is a reminder that innovation carries responsibility, and that better design can expand what is possible for millions of people. As this network grows, it also raises questions that linger just beneath the surface, creating tension between ambition and consequence. Filling the sky with moving points of light challenges existing norms about space, regulation, and sustainability. It forces us to consider how far innovation should go, and what trade-offs are acceptable in the pursuit of connection. These questions do not weaken the vision. They sharpen it, demanding thoughtful solutions rather than blind momentum. The true test of any transformative idea is not whether it disrupts the past, but whether it can endure the future it creates. And as Starlink continues to rise and circle the planet, one thing becomes clear. Choosing low Earth orbit was not merely a technical decision, but a philosophical one, setting the stage for a larger reckoning about how humanity chooses to connect, innovate, and move forward together. In this unfolding moment, the lesson reaches beyond satellites and into personal ambition, reminding us that progress often begins by questioning altitude, distance, and perspective in our own lives. When goals feel slow or dreams feel delayed, the problem may not be effort, but positioning. Getting closer to the problem, reducing unnecessary distance, and designing systems that favor responsiveness over convenience can change outcomes dramatically. Starlink's low Earth orbit choice becomes a metaphor for focus, urgency, and intentional design. It suggests that waiting above the world is safer, but moving closer is transformative. That tension builds quietly, because every breakthrough invites resistance, and every bold move attracts doubt. What happens next depends on whether this vision can balance speed with responsibility, scale with care, and inspiration with discipline, as the world watches the sky and wonders how much closer the future can really get from here. The deeper you look into Starlink's design, the more you realize that the real disruption was not just about faster internet, but about refusing to accept inherited constraints. Medium Earth orbit and geostationary orbit had long been treated as the natural home for communication satellites because they were stable, predictable, and familiar. One satellite could hover over a fixed point on Earth, quietly doing its job for years. That comfort came with an invisible cost. Latency so high that every digital interaction felt like shouting across a canyon and waiting for an echo. Starlink stepped into this quiet complacency and introduced motion, density, and proximity as tools for change. Low Earth orbit satellites do not sit still. They race around the planet, demanding constant coordination, rapid handoffs, and relentless precision. That chaos, when mastered, becomes speed, and speed changes everything. Altitude is not just a number measured in miles. It is a measure of patience imposed on users. When a signal must travel tens of thousands of miles to space and back, physics enforces delay with absolute authority. No amount of software optimization can overcome distance. By lowering altitude, Starlink shortened the path, cutting latency to a fraction of what legacy systems could achieve. This shift reshaped the user experience in ways that statistics alone cannot capture. Online learning becomes interactive instead of passive. Remote work becomes collaborative instead of isolating. Real-time communication stops feeling like a technical miracle and starts feeling normal. These are not small improvements. They are qualitative changes that alter how people relate to technology and to each other. But the story grows more complex as the network expands, and this is where suspense quietly enters the narrative. Low Earth orbit demands scale, and scale introduces fragility. Thousands of satellites must work in harmony, avoiding collisions, managing debris, and adapting to atmospheric drag that slowly pulls them back toward Earth. Every benefit comes paired with a responsibility, and every design choice opens new risks. The closer satellites are, the more frequently they must be replaced, updated, and monitored. This creates a relentless cycle of launch, operation, and renewal that tests the limits of engineering discipline and organizational focus. Success is no longer about building one perfect machine. It is about sustaining an evolving system under constant pressure. This approach mirrors a broader philosophy, often associated with Elon Musk, one that prioritizes rapid iteration over static perfection. Instead of building something once and hoping it lasts forever, Starlink embraces continuous improvement, learning from failure rather than hiding from it. In this mindset, mistakes are not endpoints, but data points, guiding the next launch, the next update, the next refinement. This way of thinking is uncomfortable for industries built on long timelines and minimal change, but it aligns with a world that moves faster every year. Connectivity is not a finished product. It is a living service that must adapt to growing demand and shifting expectations. As the network grew, skepticism followed closely behind. Critics questioned whether low Earth orbit could truly scale, whether interference, congestion, and regulatory hurdles would slow progress to a crawl. These doubts created a moment of tension, a pause where the future of this bold experiment seemed uncertain. Would the advantages of proximity outweigh the complexity it introduced, or would the system collapse under its own ambition? This is the point where many disruptive ideas falter, not because they are wrong, but because they demand endurance beyond initial excitement. Starlink's challenge was no longer to prove that low Earth orbit worked, but to show that it could work reliably, sustainably, and globally. The answer emerged gradually, through performance rather than promises. Users in remote regions began reporting speeds and responsiveness once thought impossible outside urban fiber networks. Emergency responders relied on connections that did not fail when ground infrastructure collapsed. Entire communities gained access to the digital world without waiting for cables that might never arrive. Each success reinforced the original decision, transforming skepticism into cautious respect. Yet the suspense never fully disappears, because a system this ambitious must continuously earn its place. Every launch, every update, every orbital maneuver carries the weight of expectation. At its core, the choice between LEO, MEO, and GEO reflects a deeper human dilemma, whether to prioritize ease or impact. Higher orbits offer simplicity and familiarity, but they lock users into compromise. Lower orbits demand effort, risk, and constant attention, but they reward that investment with performance that reshapes possibility. Starlink's disruption of legacy satellite internet is not an accident of technology. It is the result of choosing impact over comfort, proximity over distance, and responsiveness over tradition. That choice resonates beyond satellites, echoing in any field where progress feels stalled by inherited assumptions. The tension remains unresolved, because innovation never truly rests. It advances, pauses, adapts, and advances again, leaving us watching the sky, aware that the future is closer than it used to be, but still dependent on the courage to keep it there. As the final picture comes into focus, the meaning of Starlink's decision reaches beyond satellites and into the mindset of progress itself, because disruption is never just about replacing old technology, but about replacing old thinking. Low Earth orbit represents a refusal to wait, a refusal to accept delay as normal, and a refusal to believe that distance should decide who gets access to opportunity. When Starlink chose to operate closer to Earth, it chose to operate closer to human needs, shortening not only signal paths, but also the emotional gap between people and the digital world they rely on. This closeness redefines expectations, teaching users that fast, responsive connectivity should not be limited by geography, income, or infrastructure. It sends a quiet but powerful message that the future does not belong only to dense cities and wealthy regions, but to anyone willing to look upward and demand better. This philosophy aligns with a broader vision of exploration and expansion, one often associated with Elon Musk, where technology is not an end in itself, but a tool to extend human capability. Starlink's constellation is a reminder that solving big problems requires zooming out to see the system and zooming in to challenge its weakest assumptions. Legacy satellite internet was built around the idea that being far away was efficient, that fewer satellites at higher altitudes meant less complexity. Starlink inverted that logic, accepting complexity to gain speed, resilience, and adaptability. In doing so, it demonstrated that innovation often lives on the uncomfortable edge between what is safe and what is necessary. The willingness to operate there separates incremental improvement from genuine transformation. As users experience lower latency and higher speeds, something subtle but profound changes. Technology stops feeling like a barrier and starts feeling like an extension of intention. When a video call flows naturally, conversation deepens. When online tools respond instantly, creativity accelerates. When access is reliable, trust grows. These effects compound quietly, reshaping education, commerce, healthcare, and emergency response in ways that statistics struggle to capture. Starlink's low Earth orbit choice becomes a catalyst, not just for better internet, but for a more connected global culture, where ideas move as freely as signals across the sky. Yet the future remains unwritten, and that uncertainty is part of the story's power. Maintaining thousands of satellites, managing orbital traffic, and addressing environmental concerns will require constant vigilance and innovation. The same boldness that launched this network must now sustain it with responsibility and foresight. Progress without care can become recklessness, and ambition without discipline can unravel. The challenge ahead is to prove that speed and stewardship can coexist, that expansion does not have to come at the expense of stability. This ongoing test adds weight to every success, because each moment of reliability is earned, not assumed. For viewers, the lesson embedded in this story is deeply personal. Starlink's disruption invites reflection on how often we accept delay, distance, and limitation in our own lives without questioning their necessity. How many goals feel out of reach simply because they have been placed too far away? How many systems, habits, or beliefs operate at a metaphorical geostationary orbit, distant and unresponsive, when they could be brought closer with deliberate effort? Low Earth orbit becomes more than an engineering choice. It becomes a metaphor for focus, urgency, and engagement. Getting closer to the problem often reveals solutions that distance hides. The legacy of Starlink's decision will not be measured only in megabits per second, but in the expectations it sets for what technology should deliver. Once people experience responsive connectivity anywhere, the idea of settling for less becomes harder to justify. This rising standard pressures industries to rethink outdated models and pushes innovators to aim higher by moving closer. It reminds us that disruption is not about destruction, but about alignment, aligning tools with needs, systems with users, and ambition with reality. That alignment is what transforms bold ideas into lasting impact. As the satellites continue to sweep across the sky, they trace more than orbital paths. They trace a philosophy in motion, one that values speed with purpose and scale with intention. The choice of low Earth orbit symbolizes a broader truth about progress, that the future favors those willing to challenge inherited assumptions, embrace complexity, and design for human experience first. In watching this story unfold, viewers are invited not just to understand the technological shift, but to internalize its message. Progress accelerates when we reduce unnecessary distance, when we choose proximity over comfort, and when we refuse to accept that things must remain the way they have always been. This is why Starlink disrupted legacy satellite internet, and why its impact extends far beyond connectivity. It stands as a reminder that innovation begins with a question, gains momentum through courage, and endures through responsibility. The sky above is no longer just a boundary. It is an active layer of human ambition, constantly moving, constantly adjusting, and constantly challenging us to think differently about what is possible. And as this chapter continues to unfold, one thing remains certain. The closer we bring our ideas to the people they serve, the faster progress becomes real. If you are benefiting from our topics, please subscribe, like, and turn on the bell notification so you can see our new videos early.